Good morning, everybody. I'm really very pleased to welcome you to what will be a lively conversation. And I especially want to welcome alumni joining us for homecoming and an unbeaten Cal team, I might say. The first time in many years that we've had an unbeaten Cal team. And I want to welcome all of you and current students and their families. I'm delighted to see so many of you who are interested in design, because we certainly are here. Giving students opportunities in design to make, design, and launch innovative technologies is one of our top priorities here in Berkeley Engineering. In fact, our students are really extremely hungry for these kinds of opportunities. Dozens of student groups actually were instrumental in even persuading us to build this building. We have student groups that are devoted to designing and making, from the concrete canoe team. You know, it's a national competition to have a canoe made of concrete and a speed contest. We've been winners for, I think, the last 4 or 5 years. And we have a design and engineering collaborative as well, club. To meet this demand, and the demand of all these student groups and also a large number of classes, we opened the Jacobs Institute here this summer. Actually, August 21st was ribbon cutting day. So as you can see, you know, we've got some of the PV yet to be finished on top of the roof, and the final, you see a blue tape with the final punch list and so on and so forth. But having said that, more than 15 classes are being taught here this fall. And the building's already being used. It operates in 3 shifts. The building's open till 10 o'clock at night. We have 3 shifts of staff. A lot of whom that you see, you know, safety as a paramount concern. There are wonderful prototyping, 3D printing tools and all of that. There's a very elaborate set of safety protocols for our students and a lot of staff support. And as a result, we are able to keep this building open sort of 8 a.m. to 10 p.m. Of course, the students want it open through the night, and the small matter of the neighbors not wanting to have a Christmas tree, you know, it really looks like a jewel box at night, not a Christmas tree. And we've taken great pains to landscape it, so when those trees out there grow, it'll be just a beautiful design here, a beautiful place. The fabrication and prototyping facilities are state-of-the-art. You know, there is 3D printers, not just the kinds that you buy for a few $1,000 and you keep at home. There are sort of industrial-grade versions of them. There's sewing machines, but industrial-grade sewing machines. Everything you'd want. There is what they call fast and furious machines in the basement, which do noisy cutting and so on and so forth. There's just about every one of these machines. And we are just delighted with Jacobs Hall and the institute it houses. It houses an institute called the Jacobs Institute of Design Innovation. And that institute will offer an undergraduate minor in design innovation. So we believe that students today are hungry not only for deep majors, but they want to be able to think about the intersection of technology and art, making beautiful things. We call that the Steve Jobs effect. You know, really, Steve Jobs taught us that making beautiful things was just as important as having the cool new technology inside. And the students have responded. So it's a combination of bringing art here, bringing the best of thinking about the human experience, user interfaces, as well as cool new technologies. One thing I want to tell you about, which is really special to us here at Cal, is that this building, it's an educational building. There's a master's program, there's a PhD program, which I think Bjorn will tell you more about as well. But this building is completely supported by philanthropy. You know, the whole building. And just to tell you, Paul Jacobs was the lead donor for this building. He got all his 3 degrees here, and he felt, Paul and Stacy, his wife, got her 2 degrees here too. And they really felt that, you know, in a state school, they could bring their philanthropy to make a difference. And we provide sort of the other education at the other end of the spectrum from the massive online MOOCs, gobbledygook, you know, all of that. This is really personalized, one-on-one education. The fire marshal won't let us have more than 60 people in any one of these studios. And we have a lot of staff, a lot of dedicated faculty, and the faculty are really on board with this notion that hands-on personal education is the way of the future. You know, the way of the future, we feel, is that technology should enable us to personalize the education because everybody's learning style is different. And the only reason that we've had a more sort of mass-produced education in the past is because we haven't had the technology to customize teaching outcomes. So this will be the first place that we'll start learning how to do this. All right, so enough about me, and I'm going to get out of the way, but you know, it's a great pleasure to introduce the Chief Technology Officer of the Jacobs Institute of Design, Bjorn Hartman. Bjorn is an associate professor of electrical engineering and computer science here in the college. He received his PhD in computer science from Stanford in 2009. His research is in human-computer interaction, and it focuses on the creation and evaluation of user interface design tools, end-user programming environments, and ubiquitous computing toolkits. He's just our chief designer, you know, and this is quite a mouthful. So he co-founded, before he did this, a precursor to this in Citrus. That's the Banatao Citrus Institute across the way, called the Invention Lab. And a lot of what we learn from one institute, we bring to another. And so he's going to really tell you about what goes on here. We recently also appointed a faculty director, David Dornfeld. We have a small cadre of faculty, and those are the only ones who are resident here in this building. So please give a warm welcome to Bjorn.
Thank you, Shankar, for the introduction. Thank you, all of you, for coming out and sharing your morning with us. So I want to tell you a little bit about the brief history of the Jacobs Institute and how we're living at the intersection of design and technology. Well, maybe we'll just start with the question of what do we actually mean by design? And I like to go back to Herbert Simon, Nobel laureate and one of the preeminent intellectuals of the 20th century. He said, "Everyone designs who devises courses of action aimed at changing existing situations into preferred ones." So it involves understanding your environment, understanding unmet needs, and improving some aspect of your world through design. And as you heard, welcome to Berkeley. So you may have heard two voices in the back there. One was my son, and so I pulled out an image from one of his favorite books. You may be familiar, Richard, Scary Busy Town, just as an illustration that really all of our environment is designed, right? This building, the chairs, the hinges in the chairs, this microphone, the computer, this water bottle, everything had conscious effort into how these objects are shaped, how they're manufactured, and what their functionality is. And so really design is all around us and really pervades our environment. And so I just want to give you three brief anecdotes to show you that California actually has a very special place in the history of design. So what can we point to as kind of quintessential objects that have been designed in California, and who are these designers? Well, consider Charles and Ray Eames. Ray Eames was actually born in Sacramento, moved to the East Coast for a while, then came back, and they started their design studio in Santa Monica after World War II. And they really understood the interrelation between materials and aesthetics. And so some of the best-known objects they're known for are these bent plywood chairs. And so these chairs are aesthetically beautiful. You want to have these in your home, but they're also a manufacturing innovation. So Charles and Ray Eames were quite the experimentalists with trying out new manufacturing methods for steaming plywood, molding it into shape so it would hold those organic shapes afterwards. So that's vignette number one. Vignette number two, Wozniak and Jobs. Wozniak, of course, also an alum of Cal, who looked at the nascent electronics industry and how you could build the first personal computer out of individual components. And so the Apple I was really this tour de force of taking these discrete components and putting them together into a machine that was within the realm of a home enthusiast to buy. But maybe the bigger step came some years later with the Apple Macintosh. So this was not only a computer that would run and complete calculations correctly, but it was also one where the user experience was designed. This was the first mass available graphical user interface that introduced things like icons, menus, windows to mainstream America. And so just as manufacturing techniques enabled the bent plywood chairs of Eames, it was the electronics industry, integration, vacuum tubes to transistors to integrated circuits, that miniaturization that made it possible to build the personal computer. Fast forward another decade or two, and of course Silicon Valley has become synonymous with innovation in software, in web applications. And here are just a couple hundred of the thousands of logos of Silicon Valley startups. Many of them flame out spectacularly, but some succeed spectacularly as well. And if you think about what makes this innovation happen, well, once again, it's some underlying shift in technology. In this case, it is moving computation and storage into large data centers that make it ever more rapid and easy to try out a new idea for an application on the web. So, what are the commonalities between these three short vignettes? Well, the first one to me is that advances in design are often intricately tied to advances in the underlying technologies that are available. And it's often the designers that live at the bleeding edge of what new technologies are available that make an impact on our culture. And the second one is that design really happens at the nexus, at this intersection of different disciplines. It's engineering plus art. It's aesthetics plus functionality. Now, there are many different aspects of design, many different design disciplines. The UC Berkeley student group called the Design Council actually put up a fantastic website that I encourage you to visit, where they provide their view of how you can understand the larger space of design. So there's maybe human-centered design that is focused on human needs, engineering design that is focused on the right parameters of a structure so it performs right. There's environmental design. We have the entire College of Environmental Design here on campus, product design, game design. And this multiplicity has led to the fact that if you look across the landscape on campus, of course, you find design in many different spaces. And I think we should acknowledge that. So right here, we're in the College of Engineering. And the College of Engineering has great ties to other units on campus that also have their own design programs and that we look forward to collaborating closely with. So for example, for questions of aesthetics, there's Art Practice and the Berkeley Center for New Media. For the designed environment and design at the scale of buildings and cities and landscapes, there's the College of Environmental Design. The School of Information has a program in information design at the graduate level. Now, within the college, though, we noticed that so far, most of our offerings were at the master's and PhD level. And here it was really the vision of Paul Jacobs that said, let's fill that void. Let's take what was a volleyball court here before, and before that it was a parking lot, I believe, and put up a building that enables us to provide design education for the 21st century. And when he announced his gift at the Clinton Global Initiative, I just want to point out a couple of key phrases here, right? It's not enough to just have engineering skills. Students have to know how to work in interdisciplinary teams, how to iterate and prototype rapidly, how to think about the manufacturing impacts in terms of sustainability, and how to combine art and engineering. And this is really the vision for the Jacobs Institute here. So, just phrased in different terms. The Jacobs Institute for Design Innovation is really focused on undergraduate education, supporting students in learning design process. So, design may mysterious at first, but it is a process that you can learn, where you go through well-defined stages. It is not that you are innately born with creativity or without. This is a process that can be learned. And part of that process is understanding and defining unmet needs in the world around us. So for example, here are some snapshots of Amy Herr's bioengineering capstone, where students go out into area hospitals and observe patients, nurses, physicians, to understand their needs and come up with the new ideas. So you don't start designing out of a vacuum. You start by understanding really your environment. And then to actually do the design work, you need access to the right kind of spaces and equipments in which to design, innovate, and make. Now, as Dean Sastry mentioned in his introduction, we actually had some precursors, and I just want to point out two that I had the benefit of being involved in over the last 6 years. Back in 2010, some faculty from the College of Environmental Design and from engineering started a small experimental space called the Cal Design Lab and taught classes, workshops, put on events, lecture series over in Worcester Hall, just across campus. So this was a space focused on really a collision of people from different disciplines for the very early conceptual conversations around design. And then in 2012, Paul Wright, Eric Paulus, and I found the last open room in the basement of Satarjadai Hall and opened the Citrus Invention Lab, which was a space really focused on giving students the tools to realize their ideas. So having digital fabrication tools, having workbenches that are open and not reserved for classes to come in and do their project work. So just to lay out the larger landscape once more. So at the PhD level within the College of Engineering, there is the BID, the Design Research Lab, which has been actually around for 10 years and very successful in producing new faculty who go off into design and engineering schools all over the US and the world. And then, as Shankar also mentioned, we have about a dozen different very active student groups at the extracurricular level put on design clubs, graphic design clubs, competition teams. And on the other hand, we also have strong centers for engineering and entrepreneurship that think and touch upon design but come from a business perspective. And so the Jacobs Institute sits kind of right in the middle of this landscape. So I've told you a little bit about the vision of the Jacobs Institute, and of course you're now sitting in this beautiful building, but I want to share a couple of vignettes of how we got there. So just a little over 2 years ago, in summer 2013, I remember having conversations with other faculty members, such as Carlos Secan here in the front, John Canny, others, and just sketching what a possible home for design within the College of Engineering could look like. So here's an early sketch. That early sketch then gave way to renderings, thinking about open, flexible interior spaces, and also renderings about what an exterior of the building might look like. Well, these are very shiny. There's a long way to go from what we had to this building. So some snapshots from the construction. September 2014, excavation, a big hole, and with the excavation equipment building its own ramps to get in and out. October, more excavation, driving the piles for the building. December, rebar work for the concrete for the foundation. January 2015, false work for pouring concrete. February 2015, this was probably the most exciting month for everyone to watch, so I'll show you a quick time lapse. It is quite something to see when the structural steel crew comes in, and all of these steel columns you see around you basically went up over a week and a half. So here's a quick time lapse. Of just February. And on February 20th, just 6 months before we actually opened the building, we then had the topping out ceremony, the ceremonial placement of the last beam atop the structure.
3, 2, 1, go Bears!
Now we can declare success, right? Well, not quite. Now all we had was a steel skeleton. So afterwards followed 6 more months of working on pouring the interior floors, putting the electrical and plumbing in place, and the external facade. So this is what the building looked in July. This is what it looked like in August, just 2 weeks before the grand opening ceremony. And you should have been here during those past last 2 weeks. It was nonstop activity, 24 hours around the clock. And on August 20th, we had our benefactors and some important celebrities, namely Oski the Bear, here to inaugurate the building and cut the ribbon. So, and now you all find yourselves inside of Jacobs Hall here. Let me tell you a little bit of how this building is organized. We have 3 floors above ground, plus a basement, and the basement connects underground to Etcheverry Hall, where the mechanical engineering machine shop is located. And right now we're on floor 3 in our biggest studio, with a capacity of just about 110. And the 3rd and the 2nd floor are reserved for classes. And the classes are both classes taught by faculty as well as student-led classes, decals. The 1st floor, we very much on purpose did not schedule it for classes. The 1st floor is always reserved for students to just drop in, grab a workbench, and work on their projects. Those projects can be class-related, they can be club-related, or they're maybe an interactive art project that a group of students has an idea for. So we want to be very flexible and supportive of many different types of uses. That's a lesson we learned from the Invention Lab. So here's what these studios now look like. We just opened, actually, for classes 3 weeks ago in this building, so everything's very fresh and new still. And in addition to the classroom, off in blue, off to the side, we have various equipment rooms sprinkled throughout the building. And I want to tell you a little bit about the purpose of those equipment rooms. And what I see Jacobs Hall embodying is a 21st century workshop. And the 3 core ingredients of the 21st century workshop are powerful design software that lets students model, express, simulate what it is they want to make. Second, digital fabrication tools. So not just manual lathes and mills and hammers and chisels, but automated equipment that can take digital design files and fabricate objects out of them. And then finally, everything these days has smarts in it, so programmable electronics that add computation, communication, and interaction to the objects the students create here. And this 21st century workshop is enabled by 2 trends. The first one you're probably all familiar with. This is the Moore's Law story, right? So mainframes that decades ago cost millions of dollars, you can now have the computing power of that for hundreds of dollars on your laptop or even in your pocket. But there's a second story. There's a curve that's a bit slower, but maybe just as disruptive, and that is that we see a shift from fabrication facilities, going from industrial equipment that costs millions of dollars and only can be operated in industrial spaces, to desktop fabrication equipment that now costs thousands of dollars, pretty soon probably hundreds of dollars, that gives you that power maybe at a smaller envelope in your home studio or garage. So the first ingredient here is design software, right? Design software enables users to create detailed plans and code how their creation should look and work like. And this is where my own work as a computer scientist comes in. And this is also where some of the research tied to Jacobs Institute has already taken place. So we have a research project that brings together Berkeley and NI and Autodesk to unite these various different realms of design software that right now don't know much about each other. So mechanical design, electrical design, and code behavior right now separated. And we believe in the future they'll be much closer integrated. And then there are the digital fabrication tools, which really bring these industrial capabilities to your personal workshop. I just want to give you a tour of a couple of these. So who in the audience has 3D printed something before? Oh, just a couple of hands. OK, so then this is maybe not redundant. Here's the principle of some of the 3D printing technologies. One of the most common technologies these days is fused deposition modeling, also called fused filament modeling. And I think of this as the computer-controlled hot glue gun or toothpaste tube, which is basically you take the tube, you squeeze, and then you move it in a controlled way. Let me give you an example of what this might look like. So here's a handheld device. This is called a 3-doodler. And it extrudes molten plastic that then solidifies in air temperature. And so if you have a very steady hand, you can create these free-form shapes in 3D space. Now, I don't have a hand that's as steady as this. And so for the mere mortals among us, it makes more sense to take the same technology of a hot nozzle that extrudes plastic and put it on a robotic stage instead of a pen. And here is where the link between fabrication and design software comes in. So you start with a 3D model that you've created in your design software. And then algorithms take over and take your 3D model and slice it in many small slices. And each of that slice is basically a shape in a plane. And then you just tell a robotic arm to draw each of those shapes, move your build area down a little bit, draw the next slice, move the build area down a little bit, draw the next slice. And that then looks like this. So here's a consumer-grade 3D printer using this technology. Printing, I think in this case, it's a boat. Now, one area of future research, which we're very interested in, is this is a slow process, right? This is significantly sped up. It would actually take 3 to 4 hours to print this boat. And so maybe you're interested in our design activity later on this morning, which is taking place on the first floor. And on the first floor, you'll see our technicians, in this case, Chris here, with a whole bank of these types of FDM 3D printers that you can use later on this morning. In the room behind you, that's actually our advanced 3D prototyping studio. We have different types of 3D printers that don't just extrude a single type of plastic. So the boundary these days in 3D printing is in multi-material printing, where you can print multiple colors, but also multiple material properties at the same time. And so that allows you to do flexible and rigid objects all at a time, or transparent and opaque objects. And so what do people do with 3D printing? Well, here are a couple of examples. Here's a mathematical sculpture, 3D printed by faculty member Carlos Secan, made out of, who's standing right here in the back, who really makes these beautiful mathematical sculptures, in this case out of modular pieces that you can recombine in different configurations. Ron Rael, over in architecture, thinks about 3D printing at larger scales, and so he is 3D printing entire buildings out of cement and new types of binder. But really, some of the most exciting work is in using 3D printing to empower people to improve their lives directly. So there are initiatives like the Enable community that is creating plans to 3D print prosthetic devices, such as hands. So these may not be quite as functional yet as the highest fidelity object that you can get from a biomedical company, But you can involve a child or someone with different abilities in the creation and customization of that, and that is really powerful. So here's, for example, one of these enable hands in action, allowing a child to play fetch with his dog. And so we have some of our students actually working with people in the community to build and customize these models. That's 3D printing. That's not everything. So let me just quickly show you a couple of other tools. For example, there is laser cutting. Laser cutting takes a laser beam and focuses it on a part of flat 2D material. And it basically vaporizes that material and allows you to control very precisely what kind of shapes you want to cut out of wood or acrylic. If you scale that up a little bit, you end up with CNC routing. So here you basically have a very quickly spinning routing bit, and this is a 4x8 sheet of plywood. So this lets you do furniture scale projects. You take that same technology and shrink it down to drill bits less than 1 millimeter in size, and you end up with machines that you can put copper-clad boards in, and you can make your own electronic circuit board in the matter of an hour or so. And all of this equipment is distributed around the different workshops here. So we let students come in and play with some of the consumer 3D printers and laser cutters first, and then with additional safety training, they can get access to multi-material printing, CNC routing, etc. So that's a quick overview of the 21st Century Design Workshop, which I think really brings together all of these aspects that you saw in the design vignettes, right? There are machines for mechanical fabrication, working with wood. There are machines for working with electronics, and then there's the entire layer of software on top of that. Now let me show you a couple of example projects that students have built both this semester and over the past year in the Invention Lab in preparation for the opening of the Jacobs Institute. So I teach a course called Interactive Device Design, where students from a number of different departments come together and over the course of a semester go from a napkin sketch for a new smart product such as a Fitbit or a Nest thermostat to a fully working 3D printed programmed prototype. One group, for example, created Flow. We are in a drought in California, so this is a fixture-level water monitor that you just screw in right in front of your shower head. And then you kind of don't want to plug an electronic device in that's living in your shower, right? So they 3D printed basically a small turbine with magnets on the perimeter that will induce enough current when it spins from water rushing through it to power a microcontroller and a small radio that can sense the amount of water flowing through and send it to your smartphone nearby. And then, of course, students mostly live in shared housing, and so for this group it's very important to have a feature by which you can request a shower and say, buddy, get out, it's my turn in the morning. One of the other groups worked with local industry, so we're not far away from Napa Valley. And so these students went and visited wineries to find out about pain points in that industry. And one is to keep track of the fermentation process. So fermentation can run awry for various reasons. And when that happens, you potentially have to flush thousands of gallons of wine down the drain. And so they created this device that floats inside a tank, and it has two pressure sensors that are very precisely calibrated, and the differential in pressure can tell you the degrees Brix, or the sugar content that's still in the tank. That is then tied to a web portal, but most importantly, it'll send binary personnel a text message when something is going awry, so they can go back and add different ingredients to the tank to save that wine. Students have also been working with UCSF, with the medical school, over in San Francisco, and here we find a very fruitful model of collaboration is to get ideas from physicians and researchers in the hospital that they then bring over into our labs, and the students can build working prototypes. So this is a system called StepSense, which addresses a condition called sensory ataxia. So due to diabetes or other complications of old age, some people lose feeling, sensory feeling in their feet. And once you lose that sensory feeling, you're basically walking open loop. You don't get feedback about when your foot hits the floor. And that is dangerous because it leads to falls, and falls in old age lead to many other complications. So the clinical idea here was, well, maybe those neurons aren't working correctly, but maybe you can remap the sensation to another part of your body. And so the students came up with the system where you put pressure sensors in the soles of your shoes, and then the footfall gets wirelessly relayed to cell phone vibration motors that you wear on your back. And so every time you step, you get a little buzz on your back. And UCSF has run some experiments that have shown within 15 minutes, people dramatically change their gait with this technology. Just last semester, I taught a course together with Greg Niemeyer from Art Practice and Bob Full from Integrative Biology. So we're also experimenting with new teaching models to bring faculty from different disciplines together about interactive seating. So how can you, where are benefits from adding sensing, actuation, computation to the world of seating, to chairs? One of the teams here, the Volta team, did a beautiful job of learning how to fabricate in the wood shop and the Davis welding shop this very robust chair. And the chair has a pendulum at the bottom. So when you rock, the pendulum swings, which turns the gears, which then charges a battery. So you can imagine using that for charging your phone battery. You might have to do a lot of rocking or other uses. Maybe one final project here. Here are two undergraduates that have been working with me for a while, and they're really interested in what lies between a fully automated 3D printer that does everything for you and the hammer or jigsaw that you pick up off the shelf. And so they're investing the space of augmented power tools, so power tools that you may one day buy in Home Depot, but that give you additional help in completing your home DIY improvement tasks. So for example, they augmented this drill with some sensing and projection. And so that drill can now deliver instructions for a building project to you. So for example, it can show you these alignment guides. So you align it with the edge of a material. It shows you what the orientation is, and then it projects right how deep should you drill. And we're done. So these are some of the example projects that students are working on in Jacobs Hall. Let me just go up a level and talk a bit about the curriculum. Classes have been in session here now for 3 weeks, and both the students and the instructors just love the light-filled, flexible spaces. We counted, and our numbers were actually larger than expected. It turns out we already have 9 departments and 22 different courses here in this building, and already hit more than 1,000 students who will come in contact with Jacobs Hall this semester alone. And right now we're working on 2 different focus areas for our curriculum. On the one hand, we've introduced a new core sequence that freshmen and sophomore students can take right when they come to Cal. So we have our own course letters, Des In for Design Innovation. And this semester we piloted 3 courses, one in design methodology, one in prototyping and fabrication technologies, and one in just visual communication. How do I communicate my ideas to someone else? And these are brand new courses that didn't exist before, taught here. And then on the upper division level, we're working with instructors. We ran a grant program to see what existing and new courses for juniors and seniors there are that you might rethink and redesign to take full advantage of all the offerings that this building has. And so these are courses like User Interface Design, which has 200 students here in this building, Civil Engineering, Design of Cyber-Physical Systems, where students work with electric scooters, Interactive Device Design, the class I teach together with Paul Wright, or Product Management in Industrial Engineering. And so, for example, just from last week, here are students from all over the university learning for the first time how to not just think about analytically about gear systems, but also how to laser cut gears and automata that have to work, by the end of the afternoon. So really thinking about putting the conceptual knowledge that you get into practice in concrete projects. Another example here is user interface design, where Eric Paulus teaches a large group of students, and they're focusing really on the cutting edge of technology, working with smartwatches and thinking about how user interfaces have to change when they're not just on your phone, but they're on your phone and on your wrist at the same time. But then coming back to our students, it's not just the classes that we teach, it's also how students teach each other. And so just a week ago, the very first meeting in this room was by Berkeley Innovation, which is a student-led group. They put on a decal and also have a student group to teach each other the process of human-centered design. That brings me to the close. If you want more information about what happens in Jacobs Hall, you can go to design.berkeley.edu, which is our one-stop resource for courses, for events, and how to get access to the building if you're a member of the campus community. And I want to point out 2 events. One is later on this morning, downstairs, our fabrication session, and then our first public talk, which will take place in this room on October 16th. Thank you very much.
We want to be sure to have a few questions, and I know kickoff is real soon. Jane, you're going to lead us with who? Okay, please.
Hi, I have a
yourself
question
also, please?
about your step sense, the neuropathy. Is that something that's still under development, or is that something that people can find out and be part of a test group or something?
So it is the StepSense project. The question is, could you try it out? We're still in the early stages, so it is still a research prototype that is being tested with patients at UCSF, but right now there's not yet a way to opt into that. But hopefully, in the medical space, the cycles from having an idea to it being a treatment option that's available is unfortunately a little bit longer than in the consumer product space, but we're very hopeful. I think it's such a great idea that really is based in this insight by UCSF physicians. I would love to see it soon.
And the broader story about sort of providing clinical medical gadgets and being able to get them to the clinics fast, that's a priority, and this is definitely a big priority of the Design Institute to sort of speed up prototyping of, because a lot of these things, it's about getting them approved and getting people to reimburse, and so it's all part of this design process.
One thing I might mention to that, just to finish my answer, I think Berkeley has actually been very active in creating accelerator programs that let students who have an entrepreneurial idea incubate them within the university after they graduate for a year or so and put them in touch with the right expertise for fundraising, for manufacturing, et cetera.
And those of you that are going to the game, the accelerator space is in the basement of the stadium, so you can actually see it as you go in. Okay, more questions, please.
What is the definition of cyber-physical system, and can you give an example of it?
Yeah, so cyber-physical systems are computational systems that don't just live in the world of bits alone, but that interact directly with our environment. So think about a Tesla car. That is basically a computer on wheels that in a very intimate way interacts with the world around it. So that is an example of a cyber-physical system.
The introductory level classes, the freshman classes, are those for engineering students to get more in touch with the design side of things, or are they also open to design or liberal arts students who want a taste of engineering?
They are open to anyone, very much on purpose. So they are not restricted to engineering students, and I think we actually have, in the classes we run right now, a wide spectrum from people all over campus in those. That is by design, yes.
Yeah, as a general rule, no classes are, nothing that's offered is restricted for any college. The prerequisites are in the later classes.
Right, yeah, so the prerequisites may restrict who ends up in the class, but those lower division courses are specifically created to have no prerequisites.
So my son had heard there's a design innovation minor. Is that something that's going to be offered?
So that is still in the works, and it is the responsibility of a committee of faculty.
There's a little bit of an academic process to get this minor approved and for people to be able to put it on their diplomas and so on. That'll take a little bit of time, but it's under, it takes a few months, an academic year or so. But the classwork is off and running.
What is the course number for your interactive device design course?
In computer science, it is 294, and in mechanical engineering, it is 290. And that class is open to undergraduates and graduate students alike. That's why it has the 200 level number.
So I had a further question about the minor. Our son is very passionate about this. He said, I wish that could be my major. And who can he talk to about getting, who on the faculty should he talk to?
So
You?
So send him to my office hours, which are Fridays at 11. But we also have a student services advisor here in the building, right on the first floor, Amy Din. And so she would also be a great resource for him to talk to.
Hello, I guess I'm talking. I have a daughter here in mechanical engineering. I grew up as a machinist. Cincinnati Millicron, which is a company in Ohio, used to make all 5 functions of machining, drilling, as you showed, lathes, all just in time, bring it down and do it all at once. Do you envision this world being just in time? Totally, is that the goal of this university? And bring back all manufacturing to adjacent.
Yeah, so I think the rise of manufacturing again in the US is something we're keenly interested in and supportive of. And you are absolutely right that we're very much moving to a just-in-time batch size of 1 workflows, where everything the machine can make, one object may be different from the next one.
Can I chime in also? So, we're talking about sort of design and all of that. There's a deadly serious sort of manufacturing agenda embedded in this. The director of the institute, Bjorn's partner in crime, Dave Dornfeld, actually comes from a machine tooling background, and talk about Cincinnati Millicron and all of that reminded me of this. But just to tell you, we think, so I'm going to give you a little bit of the newest billionaire in the College of Engineering is a student called Zishang Li, who has joined this board. He said very clearly to us, he does a lot of his manufacturing in Shenzhen, and he said you have to be able to create an ecosystem where you go quickly from the designs drawn on this napkin and to be able to turn them around into hardware prototypes. And the distance between prototyping, small volume manufacturing, large volume manufacturing, all of that is growing terribly short. And so part of this bringing manufacturing, advanced manufacturing back to the United States has to start from the design innovation, but design innovation with a viewpoint to manufacturing. And when Bjorn talked about all these using fancy materials, multiple materials, it is to make sure that we aren't just prototyping with materials that don't get used in manufacturing. So that's very much embedded in the creation of the institute.
I'd like to ask 2 questions. The first one about the decal classes. Are they taught by undergraduate students, or are they supervised by professors? And the second question is, with all the wonderful designs, are students encouraged to apply for patents or?
Okay, so the answer to the first question is yes. So the classes are both taught by undergraduates, and there is faculty supervision. So for example, I supervise 2 different decals, and that means that every semester before a class starts, I meet with the students, review the syllabus they want to offer, how they will assess, how students move through, what the terms are to get credit, to make sure it is a coherent program of study. But then the courses themselves are taught by students. And that is something I think, strongly believe in and want to support, because those students who are the teachers of those decal classes, those are often also the ones who turn into leaders of their fields. And the second question, remind me, patents. Yeah. So intellectual property is an important area to learn about at Cal, and we actually have different pathways that people follow. On the one hand, there are courses offered by, I think there are programs offered by CET, the Center for Entrepreneurship and Technology, that help students think through intellectual property implications and what path they should follow. On the other hand, there's also, of course, the history of Berkeley giving away the innovations for free. So if you think about BSD, the Unix operating system, and other innovations, sometimes the way to really scale and reach the largest possible audience in the world is to open source your invention and give it away. Okay, last question.
So I'm wondering if there's, for people who are not students of the school, is there a way to maybe part-time come in or to be able to use the facilities?
So right now, the use of the facilities is restricted to current Berkeley community members. There may be an opportunity for summer programs that we may put on in the future that are open to the broader community. Give us a couple of months to get our bearings and get the current students through before we establish those. Thank you.
Thank you very much. I hope you can go to the first floor, to see some of these 3D printers in action and to design your own shapes. Thank you all very much for coming.
Thank you.